Today we're going to be factoring by grouping, which is factoring 4-term polynomials. First, we're going to start by looking at, this one has already been partially factored. And we're just going to look at something here. What do you see that is the same? If you look at this partially factored polynomial, you will notice that we have two binomials that are identical. I call this looking for the magic. You're always going to have identical binomials after it's been partially factored. And then what we're going to do is we're going to look at, whoops, there's the wrong button. We're going to look at what is left. On the outside, we have a 7 and a minus 2x. We're going to use what's outside, what was factored out, and create another binomial by putting them together. So we're basically creating two binomials. The first one, after it's partially factored, you will see, and the second one we create by what was the greatest common factor that we pulled out. Let's just look at this. If you look here again, you will notice that we have two identical binomials. That's going to be one of the binomials in our final answer. And the second one is created by what we factored out. And since this one was not, it was basically a 1 that was factored out, so we write minus t plus 1. Again, if you look at this one, if you look at the two identical binomials that are here, we have an x plus 4 and an x plus 4. So we know that's going to be one of our binomials in our final answer. Here we have that invisible 1 that's in front. So if we do the 9x plus 1, that's going to create our second binomial. Now, we have to get to that point. That was after they were partially factored. So now we're going to see how we start. This is going to be factoring 4-term binomials by grouping. Our first step when factoring is always checking for a greatest common factor. Is there something that I can factor out of all 4 terms? And looking up here, there is nothing that I can factor out. So now we're going to divide the 4 polynomials into 2 groups. The first grouping is the first 2 terms, and we're going to ask ourselves, what is the greatest common factor for 12a cubed minus 9a squared? The greatest common factor would be 3a squared. We're going to factor that out of that pair. If we divide each term by 3a squared, what do we have left? We're going to have 12 divided by 3, we have a 4 left. A cubed divided by a squared, we have an a left. We have a negative sign, so we bring that down. And the a squared divided by a squared becomes 1, and 9 divided by 3 is 3. Notice right here we have created a binomial of 4a minus 3. We know that when we factor the second grouping, we should get a 4a minus 3 because we're looking for that magic, the identical binomials. So if we look at this second grouping right here, and we want to have a 4a minus 3 left, we ask ourselves, what is the greatest common factor for this pair? We would say that it's a 5. And if we divide each term by 5, notice that we get 4a minus 3. So we have created our identical binomials. That's going to be one of the binomials in our final answer. And we create the second one by what's outside, what we factored out, and it would be 3a squared plus 5. And the question always is which binomial do I write first? Well, let's back up to the commutative property. 4 times 5 equals 20, and 5 times 4 equals 20. It doesn't matter what order your factors are in. When you have two binomials being multiplied this, you have two factors. You have one binomial being multiplied times the other binomial. It doesn't matter which one you write first, as long as you have both binomials. So if we look what we did here, we looked at this, we factored the first pair, we factored the second pair, we looked for the magic that creates one of our binomials in our answer, and then the other one is created by what is on the outside. In our next example, again, our first step is always looking to see if there is a greatest common factor for all 4 terms. There is not. So now we're going to factor by grouping. So we look at the first pair, and we look up there and decide that the greatest common factor would be 9a squared. So now we divide both of these two terms by 9a squared. And when we do that, the 9's become 1. A cubed divided by a squared is just a. A squared divided by a squared becomes 1, and 18 divided by 9 is 2. So we should create an a plus 2 over here to create the magic. And looky there, there is an a plus 2. So we have to have the invisible 1 in front of it. So now, to create the two binomials, here was our first one, here was our second one. We look for the magic to create the two binomials. On the outside, we had the 9a squared plus 1. And the inside, we had a plus 2. That created our two binomials. Okay, factor by grouping. Again, we have 4 terms. First, we always ask ourselves, is there a greatest common factor that I can factor out of the entire thing? There actually is this time. We can factor out a 2. So if we factor out a 2, we're going to do that first. And that would leave us with 48 n cubed minus 42n squared plus 56n, I believe, if I'm doing my math correctly. Now, this 2 that's on the outside becomes kind of what I call a floater. You have to have it there in order to multiply the whole thing and get back to your original polynomial. But now we're just going to look at the two pairs like we are. What we have left are 4 terms. So we're going to factor by grouping. The first group is 48n cubed minus 42n squared. We can factor out a 6n squared. That leaves, if we divide each term by n6 squared and n6 squared, that leaves an 8n minus 7. So when we factor this one, we should have 8n minus 7. So what do we factor out of that to get that? That would be a 7. Let's check that. If we did the distributive property, 7 times 8n is a 56n, and 7 times a negative 7 is a negative 49. So I know that I factored it correctly. Now you notice the magic that happened. We have created 2 identical binomials. That will be one of the binomials in our final answer. The other binomial is created from the outside, nx squared plus 7. Now we do not want to forget the floater that we pulled out. If we forgot it, when we FOILed this, when we multiplied this back, we would get back to this, but we would be not back to the original polynomial. We would have to multiply the whole thing times 2. So don't forget the floater out there that's there. Okay, another example. First, also, again, we look for the greatest common factor for all 4 terms, and I think I can pull out a 3. If I divide all 4 terms by 3, that would leave me with a 7k cubed and 84 divided by 3. For some reason, my mental ability today is a little slow. So it's 28, 28k squared plus 5k minus 20. So we factored out a 3. Now, what do we have left? We have 4 terms. And we know that when we have 4 terms, we're going to factor by grouping, which means we make 2 pairs. Look at the first grouping. We can factor out a 7k squared. And if we divide both of these by 7k squared, what we have left is k minus 4. So we should create the magic, and we should have a k minus 4 over here once we factor out something. It looks like if I factor out a 5, 5 times k is 5k, and 5 times negative 4 is negative 20, so that factors out. So I've created my 2 binomials. The first one is inside. The second one is outside, and then we do not want to forget our floater. So in our final answer, it would be 3, I'm going to erase this right here so you can see that. 3 times the 2 binomials that created, which were 7k squared plus 5 and k minus 4. That is factoring by grouping, which involves factoring when you have 4 terms.